For those of you that did not like completing the square to solve quadratic equations, we do have a shortcut, and that is called the quadratic formula. I like to start, though, with where the quadratic formula comes from. So let's give us the quadratic equation ax squared plus bx plus c equals 0. Notice we don't have any numbers except for that exponent. A, B, and C are all real numbers, so we could replace them with any number we wanted. 3, 8, 7, 20, 32. Doesn't matter. But let's solve this as a completing the square problem and notice what we get at the end. So we have a constant term. We're going to subtract that off, so we get negative c. Our equation is ax squared plus bx equals negative c. Still leaving that space. I'm going to divide each of my terms by a, whatever that leading coefficient was. So I end up with x squared equals, since my a's cancel, x squared plus, b over a x equal to negative c over a. The next step in completing the square is to take that linear term, divide it by 2, and square it. Remember, I multiply my two denominators together, so I get b over 2a, and I'm going to square that. If I square b, I get b squared, and if I square 2a, I get 4a squared. Adding that to my space, I'm going to also add that to my right side. I can go ahead and factor this, as we have in the past. My term that's going to factor into is going to be in this quantity. So it's b over 2a. Becomes a little more tricky over here. If I look at my common denominator for a and 4a squared, it's going to be 4a squared, because I can multiply a times 4a to get 4a squared. So my top becomes negative 4ac over 4a squared plus b squared over 4a squared. Notice I have a common denominator, so my x plus, this should be squared, x plus b over 2a squared equals, I'm going to rewrite this to make it look a little nicer, so my positive term comes first, then my negative. So I have b squared minus 4ac all over 4a squared. Looks a little cumbersome, I know, but in the end, we're going to get something that we can use all the time for any quadratic. We have a square, so we're going to take the square root of both sides. So we get x plus b over 2a equals plus or minus the square root of b squared minus 4ac. 4a squared is a perfect square. Square root of 4 is 2. Square root of a squared is a. Solving for x, I can subtract b over 2a from both sides. So finally, I get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Notice my denominators are the same, so I can combine these by placing them over the same denominator. So I get negative b plus or minus the square root of b squared minus 4ac all over 2a. And now you ask yourself, what in the world does that do for me? Well, remember, at the beginning we said that a, b, and c were just numbers. So if I have a quadratic equation set equal to 0, I can plug it into this formula with just my A, B's, and C's and figure out what x is. So let's look at an example where real numbers are going to come into play. I'm going to start by reminding us of what the quadratic formula is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, that's what we received down here when we solved for x. That is our quadratic formula. Let's give a quadratic equation, for example 1, of 2x squared minus 3x plus 6 equal to 0. And you're asking yourself, okay, where do I go? Well, remember, this was our a value, this was our b value, and this was our c value. We're looking for the negative of b. So if b is negative 3, negative b would be a positive 3, plus or minus the square root. I'm going to take b and square it, so I get 9 minus 4 times a times c, so times 2 times 6, divided by 2 times a. 2 times a is 4. And that's what x equals. So all we have to do is simplify this and we get our two answers. X equals 3 plus or minus square root of 9 minus 4 times 2 is 8 times 6 is 48 all over 4. Simplifying even more, inside the radical, 9 minus 48 is negative 39 divided by 4. And we have one last thing that we can simplify, and that's this negative 39. If we think about negative 39 and the square root of it, we see that negative can come out as an I. So we have 3 plus or minus I radical 39 over 4. And that's our final answer. Let's look at example 2. And really, they don't get any more complicated, unfortunately, unless we get larger numbers. So let's take example 3 as x squared minus 5x plus 4 equal to 0. Now you may be saying to yourself, hey, I think that factors. And it does. We could factor it and solve it. However, let's use the quadratic formula to show how we could solve for x using the quadratic formula if we didn't realize it was factorable. So our a value this time, notice, is 1. Our b value is negative 5, and our c value is 4. So our quadratic formula tells us the negative of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So here, simplifying, we have 5 plus or minus the square root. 25 minus 16 is 9 over 2. 5 plus or minus the square root of 9 is 3 over 2. So now we have all real numbers. We can go ahead and break up our plus or minus symbol. And we have x equals 5 plus 3 over 2. And x equals 5 minus 3 over 2. Simplifying, 5 plus 3 is 8. Divided by 2, we get 4. And 5 minus 3 is 2. Divided by 2 gives us 1. And there are our two solutions. In example 3, I want to take a look at a problem that's not equal to 0. So let's say 2x squared equals negative 6x minus 7. Since it's not equal to 0, we're going to have to go ahead and solve the equation for 0. So we're going to add 6x and we're going to add 7 to both sides. So we end up with 2x squared plus 6x plus 7 equal to 0. Now you may be asking yourself, why didn't we just move the 2x squared over? Well, in mathematics, we like to have that leading coefficient positive. And if we can do that, we'll go ahead and work it that way. If you moved it over, that's okay. Your symbols and signs would be the opposite. So again, our quadratic formula, remember, is negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's what x equals. So our x equals negative 6 from our b value plus or minus the square root. B squared is 36 minus 4 times 2 times 7. 4 times 2 is 8 times 7 is 56. Divided by 2 times a, which is 4. Simplifying, we have negative 6 plus or minus 36 minus 56 is negative 20 divided by 4. So we have x equals negative 6 plus or minus. We can reduce the square root of negative 20. Coming off to the side, the square root of negative 20 equals the square root of negative 4 times 5. Square root of negative 4 comes out as 2i, and we end up with a radical 5. So we have 2i radical 5 all over 4. At this point, we've left it, but that was only because we couldn't divide out a common factor between our whole numbers here. If you look at negative 6 plus or minus 2i radical 5, we could factor out a 2. So we have 2 on the outside times the quantity of negative 3 plus or minus I radical 5 divided by 4. Now our 2 and our 4 will cancel each other out because we can take a 2 out of each of those. So our final x answer is negative 3 plus or minus I radical 5 all over 2. And there's our final answer. And that will conclude our quadratic formula.